Alright, let's look at the scalar product of vectors. Let's say vector A has a component A1, A2, A3, and a vector B has a components B1, B2, and B3. Alright, so definition of A dot B. So this is a dot product of two vectors, vector A and vector B. This is defined as absolute value or the magnitude of a norm of vector A, and then magnitude of vector B times cosine of theta. Right. Another way is a component wise, we can compute it by A1 times B1 plus A2 times B2 plus A3 times B3. Right? So those are the definitions. In the first one, if you solve for cosine of theta, we can find the angle. So theta is the angle between those two vectors. So we can solve for cosine of theta, which is A dot B divided by the product of their magnitudes. I guess if we really want to solve for theta, we can take the arc cosine of both sides. So theta can be found by arc cosine of A dot B divided by the magnitude of A and the magnitude of B. Alright? And geometrically, dot product is very useful since when two vectors are perpendicular, cosine of 90 degrees is 0. So therefore, if you take the dot product of two perpendicular vectors, it's going to give you 0. So here's a note that vector A is perpendicular to vector B if and only if dot product is equal to 0, right? Assuming that these are non-zero vectors, right? Another way to look at the dot product is that so maybe I'm going to draw a picture. Say here's the vector vector A, and here's vector B. Right, so vector B. Right, then we know that this is going to be the angle theta. Right, so you can see that here, if you look at the projection of vector B onto, say, projection onto vector A. So this guy right here is going to have a magnitude of vector V, magnitude vector V times cosine of theta. Right? So this is the so this guy is the projection of vector B onto vector A. Right? So if you look at the A dot B, which is magnitude of A times magnitude of B cosine of theta. So you can think of this as here magnitude of A times the magnitude of the projection of B onto A. And of course, why would you project B onto A? Can we do A onto B? And if you look at it this way, say it's the same thing as magnitude of B times magnitude of A cosine of theta. And then of course, this guy is the projection of vector A onto B. Right, so you can think of dot product as the magnitude of one vector times the other vector's projection, a magnitude of the vector projection onto the other one. Right, that's it. I hope that this was clear.